Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn all about properties in C#. These are kind of a mix between a variable and a function, so you can store some data and run some logic. Okay, so properties, these are actually pretty simple to define. So we define them pretty much like a normal variable. So we've got the access modifier, so let's make it private. Then we have the type, let's say of type string. Then we give it some name, and the usual naming rule is for properties to use Pascal case, meaning uppercase on the first letter. So for example, player name. And then if we just put a semicolon, if we just do this, then this is a normal variable, it's not a property. In order to make it a property, instead of this, we open and close a code block. And now here we add two pieces of logic. One is called get, so let's do get and then a semicolon. And then the other one is called set, so let's set and then a semicolon. And if that's it, this is a super simple property. And in order to use it over here in our static main function, let's just define this one as static. So then down here in our main, we can use it just like as if it were a regular variable. So we can go inside the player name and we can set it to something like CodeMonkey. So let's do this and then do a console.writeLine and let's print out the player name. Okay, let's see. And if there it is, and it does print out the name, so pretty much the same as a regular variable. However, in reality, this is not a variable. In reality, the C# compiler is doing a little bit of magic in the background. Properties are really not variables. They don't actually store any data directly. So what we have defined here is what is called an auto-implemented property. In the background, the C# compiler is generating a hidden variable that does store data for this property. So we can also just manually do exactly that. So let's do a private static string for the player name. And again, since this one is a variable, we're going to use camel case. And then let's use it over here on the property. So inside this code block for this get and this set, we can actually expand upon it. So for the get, let's add a code block inside it. And over here, let's return our backup field. So let's just return the player name, the underlying one, okay. And then for the set, again, same thing, let's add a code block. And for this one, we want to set the player name, so player name equals, and then we use the keyword value. So this is basically going to be whatever value we assign to the player name. So when we run this line of code, it is going to run this sort of mini function, and it's going to assign the value to whatever we assign here, which in turn is going to assign it onto the underlying value. Okay, so if we test like this, and if everything still works the same, it still prints out CodeMonkey. So what we have over here is literally exactly the same as we had previously. The C# compiler simply builds all of this automatically in the background whenever we do a property where we have just a get and just a set, and we do not define any of these code blocks. Now here, the get and the set, these are pretty much functions, which means you can write pretty much any code here. For example, we can do some validation. So over here on the get function, for example, let's test if the underlying player name equals null. So if it hasn't been set, if so, then we can return some kind of default, so unknown. If we do it like this and we erase the setting, so we just have the player name uninitialized, and if there it is, now it does print out unknown. So we basically added some extra logic onto our get function. And when setting, same thing, we can also validate the value. For example, let's say this player cannot be named CodeMonkey. So we can test if the value equals, for example, CodeMonkey. If so, then either we can set the value to some default value, or for example, we can throw a new exception, cannot name player CodeMonkey. By the way, I'm going to cover exceptions in detail in a future lecture. This is pretty much just an error message. So if down here we can try to set the player name equals CodeMonkey, if we try doing this, and if there it is, right away we see an exception, because again, it is running our validation code, and our validation code does not let us name this. So usually this is the goal of properties, which is how you can do some validation for processing either the get or the set function. And one extremely useful thing you can do with properties is simply make different access modifiers for each of these. Now, right now, we made the player name, we made this one private, which means that both of these are going to be set to private. And if instead we make this public, if so, then now both these are public, meaning any class in our codebase can access either the get or the set. However, you can also add different accessors here. For example, we can leave the get like this in order for anyone to access it, and we can make the set as private. That means that this class can now access and set the value over here on the player name, but other classes can only use the get. So yep, here we do see an error. So I created a completely separate class named player, and inside I'm trying to access the player name and modify it. Nope, I cannot use it because the set accessor is inaccessible. However, if I do a console.writeLine on this one, if I do it, then yep, this is perfectly valid code. So this property can now be accessed. We can access the get from any class anywhere in our codebase, but only this class can access the set. So right now you might be wondering, okay, so is this really all the same as just making a field with some get and set functions? And yeah, pretty much it is. If we were to make a private static void set player name and receive a string for the player name, if we do this and set the player name, and then we have a private static string for the get player name, and over here we return our player name. So if we have this code and then up here, let's say we don't want any of this validation, So we just have the basic auto implement property. So just get and a set. So yep, just like this, the property that we defined up here, it is doing pretty much exactly the same thing as what we have down here. We have a field with set and get functions, and that's pretty much the same thing that we have here. So these two pieces of code, these are pretty much identical. Now, I have to say that personally, I'm not a big fan of properties, simply because I do not like how they look like variables but act like functions. Personally, I find that needlessly confusing. If I want to store some data, I want to use a variable, and if I want to use some logic, I want to use a function. Combining both in a strange way, to me, just seems really odd. It seems needlessly confusing, but that's really just me, that's just personal preference. A lot of people really like using properties. In fact, the official C# documentation is full of properties. So while personally I don't like them and don't normally use them, it's not because they're bad, it's really just personal preference. So if you do like them, feel free to use them in your projects. For me, the only place where I use properties is when I use the singleton pattern. I'm going to cover that in detail later on in the course, but over here, let me just quickly show you how the property helps implement that pattern. Usually in that pattern, you want some field to store the singleton reference, but importantly, you want only the singleton class to be able to set that field while anyone else can get it. So the property accessors are really useful for that. So usually for that, you make a public, make it static for the singleton pattern, make it of the type that you are making the singleton, so for example the program type, then you usually call it instance, and then we have a get and a private set. So yep, this way the access is exactly as intended by that pattern. We have a public property with a public get and a private set, meaning this one can only be set inside of this class, but any other class can get it. Like I said, I cover singletons in detail in a future lecture, but I just want to show that this is pretty much the only scenario where I use properties. For anything else, I normally just make a regular field, and if I need to, I make get or set variables if I need to modify. But again, it's all personal preference, so if you like properties, then go ahead and use them. Okay, so that's properties. They are a really interesting mix between a variable and a function, allowing you to handle stored data and process it in some way when getting and setting.